Good evening, everyone. Welcome to this talk, which is part of the series of Conexão Rio-Campinas, a partnership between the Institute of Computing, University of Campinas, São Paulo, Brazil, and the Pontifical Catholic University of Rio de Janeiro, PUC-Rio. Today, we have the pleasure to count with Professor Ricardo Baeza-Yates, who will talk to us about ethics in artificial intelligence, a challenging task. This talk is also organized by the Artificial Intelligence Laboratory here, Recod.ai, at the Institute of Computing, University of Campinas. Professor Ricardo is Director of Research at the Institute of Experiential AI of Northeastern University. He's also part-time professor at Universitat Pompeu Fabra in Barcelona and Universidad de Chile in Santiago. Before, he was Vice President of Research at Yahoo Labs, based in Barcelona, Spain, and later on in Sunnyvale, California, from 2006 to 2016. He is co-author of the bestseller Modern Information Retrieval textbook, which I'm sure many of you have seen or studied during college at some point. With this book, Professor Ricardo got the ASIST 2012 Book of the Year Award. From 2002 to 2004, he was elected to the Board of Governors of the IEEE Computer Society, and between 2012 and 2016, he was elected for the ACM Council. Since 2010, he is a founding member of the Chilean Academy of Engineering, and in 2009, he was named ACM Fellow and in 2011 IEEE Fellow, among many other awards and distinctions. His main areas of expertise include web search and data mining, information retrieval, bias on artificial intelligence, data science, and algorithms in general. So Professor Ricardo, thank you very much for being here today with us and for accepting the invitation to talk to us. So I will stop sharing my screen and the stage is all yours. Thank you very much.
New institute by Northeastern, the Institute for Experiential AI, that basically tries to give a pragmatic approach to successful AI. You may not know, but Northeastern started the co-op program early in the 20th century in Boston, something that Waterloo also copied later in Canada. And we think that we need to have humans involved, and not only humans in the loop, but more than that, and we'll talk about that later, but also don't have this strong dependency on data and have better algorithms, especially when you have small data. So this is what we're doing, and you can check the website ai-northeastern.edu on this new institute, led by Usama Fayad, which was the one that also created Yahoo Labs. So it's the second time I'm working with him as a well-known data mining researcher. So the agenda will have basically three parts. In the first part, I will mention what for me are the 5 main problems with AI today. And this has a personal bias. Bias is the first problem, so you need to be always conscious on the bias that you have. And in the second part, I will talk about some generic issues that are related to these problems. And then I will try to mention what we can do to partially mitigate all these problems. So let's start with the first problem, which I call the course of bias. Basically, you have biased data coming to an algorithm. Let me remember that information is biased in some sense, because if you have white noise, you can't do anything. Also, the first bias we have here is that when we hear the word bias, we think in something negative, but bias is not necessarily negative, it could be positive. So in general, it's neutral. It's just a systematic deviation to a reference value. One problem that sometimes we have is that we don't know the bias. And even when we know it, we don't know the reference value. For example, what should be the right proportion of women in every, for example, in every kind of work. This is something that sometimes needs a cultural consensus, and it's not something that the computer scientists will decide. So this is the situation, and then a natural question to ask is the algorithm should be neutral or fair. But normally we don't ask this question very often, and we get the same bias input. Even worse, sometimes we get amplified bias. And if that's the case, we cannot say that it's the problem of the data. Indeed, in most cases, bias comes in the data, but bias is not only in the data. And if you want to read more about this, you can check my bias on the web paper on publication of ACM, June 2018, where I go to the overall vicious cycle of bias in software systems in the web that can be applied to any software system in the world. So what it means to be fair? So that's not easy. So that's it's complicated. So here is a cartoon that explains the difference between equality, equity, justice. Justice takes a long time, so usually we cannot ask for justice, and we basically satisfy ourselves with equity, and they're here to have affirmative actions. So affirmative actions try to change some discrimination, like Iceland that now has a law that forces companies to give the same salary for the same work to women and men. So if you're interested in this topic, I strongly recommend this documentary done by mainly Black women in the US, Coded Bias. It's in Netflix, and it's translated to Portuguese. Much better than the social dilemma of last year, mainly done by white men. We had a very interesting debate about this documentary in March in the ACM, where I was representing half of the population. I had that honor, and we had a federal judge, a former president of ACM, and two very well-known risks on privacy and fairness. That's available in YouTube if you want to hear the discussion. Well, so what is the answer to this question? Well, the question is that as all the complicated problems, the answer depends. Not always you need to worry about these questions. However, and I will get back to this in all my talk, if you harm people in any way, you need to answer this question. You need to take care of this question. Now, how you solve that, that will be a completely different talk, but you can always try to mitigate the input. People talk about the biasing, but you cannot fully debias a data set because you don't know all the biases that are in there. That will be the best way, but as I said, we do not know all of them, and also we don't know many reference values that we need to use. The second possibility is that the algorithm is about the bias, and you can tune the algorithm. For example, that happens in learning to rank with ranking bias, because people click more on the top positions on search engines. You have to basically debias that to avoid fooling yourself, thinking that the best positions are the best. And finally, you can always debias the output, but then you already lost a lot of information. For example, you search on LinkedIn and you get 40 men, 10 women, you cannot do gender parity. The best you can do is gender parity in the top 20. So the first time that discrimination, I guess, reached the headlines was in 2016, when ProPublica basically reported that a system used for recidivism, difficult word in English, Compass, had a racial bias. Many people have analyzed this problem later, and even people, some claim that this is not. In general, this is the case. And then here we have the first fundamental question of this type of algorithms that are being used by the government. So is this algorithm ethical? And the question is, we want more transparency. We want to be able to understand what the government is doing. Now, we say ethical, but algorithms cannot be ethical. They are not humans. But let's use this metaphor. And then we need to ask a second question, is a public algorithm safe? Because if I know exactly how the algorithm is coded, then maybe I can game it and can manipulate the answer, and then I can fool the system. The right answer should be between, and no one has a fixed answer, because that depends on the context of where we're solving the problem. Other systems like, for example, Godam, that is from Palantir, are being used for filing. Basically, like Minority Report, predicting if you will be a criminal before you do something. And this has been mainly used in secret in the US police in some big cities, but also have been used in some European countries. The problem is not when it works, the problem is when it fails, and then you make one error that changes the life of a person. Another example is Paul in the Chicago metropolitan area. And here, just I want to show you the problem of measuring that is also biased, because if police goes to certain places, you will measure more crime there, and then you enforce your beliefs about where there are crime, because in places where police is not there, not all crime is reported. So you reinforce the bias. There are other more unethical cases like this tool being used in Spain, where basically it's like a lie detector for victims. So basically, are you saying the truth that someone stole your wallet or not? And here is already an ethical issue because you are applying this to the victims, not to possible offenders. And this happens also in Germany, but immediately a party went to court to challenge this. And certainly we have to see what happens, because this recent February, what is the result of that challenge. Now, let me give you a very interesting example, one of the best examples I've seen of a very detailed analysis on basically discrimination in justice. So this is a problem of giving bails to people in the state of New York. So you have an offender and the possible offender, and the judge has to decide if you get bail or not. In most places in the world, you need to think if the person will reoffend and if he will appear in court. In New York, the judge has to decide only based on if he will appear in court, which is already difficult if you have, let's say, a serial killer. Well, if you get bail and pay, you get out. If you get bail and cannot pay, there's always a person in the US that lends money to people to be bailed. And this person has to do the same prediction of the judge, right? One problem in this kind of settings is that we do not know part of the picture. So we don't know what will happen if a person that didn't get bail will have that bail, and for example, if the person would have reoffended or not appear in court. So for this, we need to do data imputation, which is something that complicates this problem. And then you need to have part of the data only to impute and predict possible outcomes in the system. So what were the results of this paper by Klember et al.? So very famous researchers here in a work that was requested by the National Bureau of Economic Research of the US, not by the National Bureau of Justice. They want to spend less money in prisons. And they got that they could decrease the crime rate in 25%, keeping the same jail rate, or they could decrease the prison rate in 42%, keeping the same crime rate. And if the predictions are correct, remember these are predictions from the system, half of the most dangerous criminals were free, and they reoffended or didn't appear in court more than half of the time. So this is how they did the data in different sets. I think I will skip this. We don't have much time, but they use gradient boost decision trees, which are nonlinear decision trees and allow some interpretability. They didn't have enough data to do, say, deep learning, only less than 1 million cases. And the only demographic variable was the age of the person. Not even the gender, because most of them are men, so gender would not have done much. But there is no really variable where you can, for example, deduce the race of the person, like address or name. Well, what were the results? I already mentioned the main results, but if you see the distributions of defendants, most of them are from Black or Hispanic origin. So you have 82%. And here I put it the percentage in practice in the population. So already you have a bias on the people that reach the court. Now the judges increased the bias. Basically, they increase the percentage of Black people. They decrease the percentage of Hispanic people, maybe because they're more white there. But still the minority population goes up to 89%. What happened with the algorithm, with the model? Well, the algorithm learned to be racist, even more racist than the judges. So the percentage of Black people went from 57 to 60%. Decreases also the same for Hispanic population, but in total, 90% of the people were of these two minorities. However, because it's an algorithm, we can tune the algorithm to match, for example, the less racist judge, and there, still there, you can get an improvement of 23% on the crime rate. So what is happening? Well, this picture shows very well what is happening. Assume the predictions of the system are correct. If you want to send additional people to prison, you see the algorithm will take the top candidates, so the ones that are more dangerous. However, if you see what judges will do, and judges were divided in 5 groups to do the data imputation, so I don't have time to explain that. But basically, they use soft judges to predict hard judges. You see that they are basically sending people to prison or free in a random way. So it's not really similar to the algorithm. So here we have a dilemma. The dilemma is, what do we prefer? A biased algorithm that in some sense is just because for the same data gives the same answer, or we want to have a noisy judge because the judge doesn't decide all the time the same. Now, not all judge decisions may be a mistake. For example, sometimes you need to free a person even if you don't want to free it because the law says that. So here the context is missing, and no algorithm will have the context of the judge. So this is the problem because justice is something human. The algorithm doesn't know things that we know. So it's very hard to say what is right and wrong here. I was using a very interesting article from Daniel Kahneman and co-authors that was published in 2016 in Harvard Business Review, but recently Daniel Kahneman and 2 colleagues published a book last May called Noise, a Flaw in Human Judgment. And the difference between machines and people. At least machines don't have, so this is an advantage. On the other hand, they don't understand the context and have other limitations that I will mention later. So there are many examples of this discrimination. For example, I would say the one that you see more in the news have to do with facial recognition. This was very clear in 2019. Then was very clear with the documentary that I just mentioned, Coded Bias, in last year. And at the end, basically, there is also an ethical component here, because if you check from where the images came to develop facial recognition, most of them came from the web in the last, say, 14 years. Of course, these pictures had no consent. So all the technology also basically was developed without the consent of people's faces. So because of all this, in June last year, Amazon, Microsoft, and IBM decided to stop selling facial recognition to police. For example, IBM had a very good reaction to this documentary. Amazon had a bad reaction to this documentary, basically saying that they were doing well. Also, the ACM Technology Policy Committee did the same statement. I participated in the statement of part of the committee in June 30 last year, but then it was too late. Why? Because the system was already being used, and in September, another person was falsely accused, Black person, of a crime because of the systems. There are other problems like gender bias, and this is an example that doesn't work any longer, but shows very well the problem. So I write, he's a babysitter, she's a doctor. I translated to Turkish. I don't know any Turkish, so I cut and paste. And I translate it back to English and says, she's a babysitter, he's a doctor. Well, now they have fixed it. Both are female. So I guess this is an affirmative action. They are doing positive bias. However, if you put many sentences, it doesn't work. So for 2 sentences working, for 1 sentence, they will give you the 2 genders. And there we have a problem with that gender is, we know it's not binary, and then it's more complicated. But this happens also in stereotypes. So this is a very, very famous paper on Newlip's 2016, where if she's a nurse, then he's a surgeon, or if he's a superstar, she's a diva. And we know that there's some negative connotations to diva. So after seeing this, I basically did some research to say, okay, most journalists in the USA should be men, and this is true, but I found out that most students in the US are female. So there is basically there's a racism, sorry, there's a gender bias only to get the job. Another stereotypes, for example, this is a paper from Stanford, and you can see here that Hispanic, you are the driver, but if you're white, you are the sheriff or the administrator. So clearly also this is tied to ethnic origins. And then even religion. So here are the size of language models. So language models are very large word embeddings being used to generate text. And here you can see that the largest model known from Google has 1.6 trillion parameters. This is comparable to the size of words in the web. And for example, a recent paper showed that this anti-Muslim bias. So basically, if you write two Muslims walked into, and then you ask GPT-3 to complete this sentence, most completions will be violent. In fact, will be 4 times more violent for Muslims than from Christians. And I guess the good news is that for Buddhists and atheists, we are the most Pacific people, at least in the news in the web. But can be much more complicated. So, for example, last year when the UK decided to predict the score to enter the university, they discriminated poor people. Or more interesting, when January this year, Deliveroo was accused of discriminating riders. This is like Glovo or Rappi. They found out that the system itself learned to discriminate people that couldn't deliver food at night. And the judge said that indirect discrimination because the algorithm was not checking why these people couldn't deliver at night, like having dependents, or in the last case, not wanting to work at odd times. And other cases, for example, end of last year, 6 drivers sue Uber in Netherlands. These drivers were in the UK and Portugal because they were basically fired because an algorithm said that they were cheating. And at the end, they won the case because Uber decided not to present in the court. Maybe because they didn't want to share the code, but basically they didn't defend themselves. And the worst example, the last one, is maybe what happened in Netherlands early this year too. The whole government had to resign. What happened during many years in the past decade, there were several algorithms were being used to discriminate people, for example, in child benefits, trying to find fraud there. That affected 26 associates that were accused of fraud, and they had to return a lot of money. Some people lost their jobs, their houses, so they had to go back to their countries of origin, and this, of course, affected poor people and immigrants. Was not enough that the former minister resigned. She was part of the parliament. The whole government had to resign. And this is just a sample of cases. There are hundreds of cases of discrimination of the thousands that you can find in this place, incident database.ai. Let's go to the second problem. The second problem is physiognomy. I don't know if you, when you study philosophy at school, you learn that there are different kinds of people depending on the shapes of their face. And we know that's not true any longer. But some people is using AI to do this. For example, Kosinski at Stanford used facial biometrics to predict sexual orientation. Of course, the people were not happy. Before, some people in China were using your face to predict if you will be a criminal. So again, Minority Report. And last year happened again in the US, in spite that there was a lot of controversy a few years earlier. And this year, Kosinski came back and he said that using facial biometrics, he can predict your political orientation with 70% accuracy. Well, 70% accuracy is very easy to achieve with basically spurious correlations. Maybe the hair, the clothing, even if you use some in your face and so on. And this is kind of a modern phrenology. So phrenology was something that started end of the 18th century and was very popular in the 19th century. For example, one of the main people behind this was Dr. Cesare Lombroso in Torino, Italy, that collected hundreds of skulls because he believed criminals had a different skull. And he was really consistent with his belief because he also left his skeleton for posterity. I guess that this is for him the ground truth of a good person that collected bodies from the morgue that nobody wanted, so only collected poor people. And you can visit his house in Torino, and it's very interesting. Although it's sad that the person did this. But it can be worse. In 2019 in MIT, they published a paper in CDPR, a very well-known conference, that claims that given a piece of audio of your voice, they can basically predict your face. So I have my master phrenology algorithm that with you send me a piece of voice through WhatsApp, I will predict your face, and then I will use your face to predict your name. Yes, there's a proposal for a patent from Mitre that says that they can predict your name from your face. I don't know what they do with all the adopted children from different cultures. And then I can know if you're an opposer politically or homosexual or criminal. Not only this doesn't work scientifically, there's no causality, but also this is not ethical. So there are two problems here, and you see these problems in major universities. So the IRBs are not working, and basically there are no real ethics board to check this thing, not even in the journals in the conference. And this can be even more subtle. So a lot of people is using facial biometrics to recognize emotions, and this recent work from a famous neuroscientist from Northeastern, Lisa Feldman-Barrett, she has great TED Talks on emotions, basically shows that people cannot predict emotions. So if people are labeling data and they cannot predict emotions, of course, AI cannot do it either. We are just rediscovering the stereotypes that work part of the time, not all the time. And please don't try to use your face for anything related to personality or emotions. Fourth problem, unfair e-commerce. And this is important because we are all here. This is not something that affects only women or minorities. This affects anyone. So, for example, I know many people in the crowd, like my dear friend Ricardo Baeza-Yates. I can offer him something that I know he likes, but it's very hard to offer him something he doesn't know that if he knew it, he would like it. That's the filter bubble problem. And some people want to get out of the bubble, like Truman in the Truman Show, but many people is very happy on their false news bubble, and we have seen that in all elections. Sadly, I saw it a few days ago in Chile. And systems are using things like diversity, novelty, serendipity to break this personalization bubble. But it's even worse, because if you're exposed to 3 recommendations of thousands, it's not like seeing the top of the iceberg. It's basically seeing the ice cube on the top of the iceberg. You are seeing 3 of thousands. And then the system itself is in a bubble. And this is the problem I'm doing research today, because this not only generates a popularity bias, but also creates unfair markets that in the long run are very unhealthy and very unstable, and also discriminate people in the long tail. So basically we have what is called the Matthew effect. The rich get richer, the poor get poorer. We are only increasing the inequality that already is going very fast in the world. Fourth problem, stupid models. In 1979, George Box said all models are wrong, but some are useful. He was talking about the statistics. We can say the same for machine learning. Let me give you some examples. In January, when Elon Musk said use Signal, and he was talking about the chat app, some software that used Twitter data from influential people started to buy a stock from this company in Texas, Signal Advance, and the price of the company went up 400%. So a lot of people lost money, except this company. But of course, there was no semantic understanding of what Elon Musk was saying. Or even worse, here you see on the right a typical example of adversarial AI, where if you change one pixel, you see the white pixel, so you change that pixel, and a horse becomes a dog, or a car becomes an airplane. Or even worse, this will sound funny. Some engineer in Facebook decided to use an English trained system for basically bad words, and took away the page of the town of Vichy in France. And this town was 3 weeks without their page because there was no human in the loop to see the complaints. And this is not funny if they're using, for example, this page for informing about it. So even things that look funny may harm people. So we need to understand the limitations of technology. And I think that many computer scientists believe that they can do anything and they can achieve general intelligence when that's not true. For example, the first thing is that to abstract, you need to forget, filter what you learn. Here, I like to remind the amazing short story from Borges, Funes de Memorias, that basically was a person that couldn't forget anything. And if you find him in the street and you say, what happened in the last hour, you will need to wait 1 hour. So he tells you exactly what happened in the last hour because he cannot forget anything, he cannot summarize, he cannot abstract. Very important, another important limitation, you cannot learn personal data. Sadly, this is what happened in Arizona when a self-driving car killed a woman because in the data there was no person crossing at night in a bicycle in a place where you should cross. And sadly, the person that was inside the car was looking at the cell phone, so couldn't act on time. Accuracy is not the key, it's the impact of errors. I don't care if you work 99% of the time well. I care about what you do with that 1% of the errors. So I'm working on this, on how to really evaluate based on harm and not based on success. And remember, for all the computer scientists here, be humble. An intelligent person, when doesn't know, says doesn't know. Especially if you're a teacher, you have to say, I don't know. Today, I'm seeing many classifiers that even if you have confidence 0.5 or 2, they say something. Don't say something that you are not sure is true. And the last problem is the waste of resources. So related to green computing. Again, I get back to this table of the language models, where they show that, for example, to train a transformer architecture, you need basically 57 years of the carbon print of a person, a standard person in the world. Or even worse, you need to spend $1 to $3 million in resources for this. So not all people can generate these models. And this is part of the content of this very famous paper now. Maybe some people know it's here, the Stochastic Sparrow paper that meant that Trinity Gabriel was fired from Google. She was the co-leader of the AI ethics team. And that implied that Margaret Mitchell couldn't put her name, the other leader, in the paper because Google forbid that. But you can see her name. But that didn't matter because she was also fired using an ethical argument because she was checking her email, but it's forbidden to check any email, including yours. But this is not new. For example, in 2019, when Google tried to do an ethics board, had to dissolve it in 1 week because they chose people not too ethical. So this is the meta ethics problem of the industry. And this is not only true for Google, but also true for Facebook, Amazon, and so on. So this leads to the second part. The second part has to do with generic issues. The first one is properties a software that is transparent and accountable should fulfill. Here are the 7 properties that the ACM proposed in 2017. Most software don't have these properties with awareness. And we need to remember that systems do not need to be perfect, but seems that they need to be much better than us. Why? Because people is much harder judging machines than judging people. So to err is human, but not for a computer, although they are learning from us. And you can check this in the recent book by my fellow Chilean Cesar Hidalgo on how humans judge machines. I believe that you can still get a digital version for free on this website. So there are pragmatic questions here. So which properties we need to fulfill in software that will be responsible? And there are many questions that I will not answer because there are no clear answers, and also because this would take another talk. So I'm working on a paper that basically I checked 30 different properties of software, and I classified them to which part of the system applies and to whom they are important. And based on this, I have my own classification, my own taxonomy of these properties that are divided in 6 groups: awareness, data provenance, completeness, usability, transparency, and responsibility. And you see here that the ACM ones are underlined, and of course, there are many more that are important. There are people already working on this kind of software, like Ben Schneiderman. We have a group of people interested in this in a very interesting mailing list that he has. And he uses the word trustworthy. I prefer not to use trustworthy because I believe we cannot trust this software. We know that we'll make mistakes. I prefer to use responsible AI because we know that they will fail, so we need to make sure that we'll be accountable of those mistakes. So the next should be how we can develop software that is responsible with the help of AI. So AI helping to solve the problems of AI. Regarding culture, there are differences between Christians and Muslims, but I want to point out only one interesting view from the south of Africa, Ubuntu. Ubuntu basically says that I am because we are. So that is not the person who is important, it's the group which is important. And if you have read about the Dunbar number and that we originally were tribes about 150 people, basically we are social species. We don't live alone like say a polar bear. So there's a very interesting essay by Abeba Birhani that said that Descartes was wrong because a person is a person through other people. And then we have issues on identity, data protection, and privacy. These are not the same thing, so I can be completely anonymous, but maybe I will be able to share part of my data. There are also legal issues like freedom of expression, when I can do everything that's not forbidden, against data protection rights, where I can do only what is allowed. And Brazil basically took GDPR as a base for your new law of data protection. Here we have issues like minimal data collection that is not fulfilled, or minimal time stored that also not fulfilled for many apps and many other applications. If you're interested in the topic, I recommend Privacy is Power, that is translated to Spanish and Portuguese by Carissa Vélez. So in the Article 22 of GDPR, just read the last line, says that a person can contest the decision. What that means for us, for computer scientists, that means that if you want to give individuals information about the processing, then you need to have interpretability. If you want to explain a decision to a given person because of a particular data, you need to have explainability, completely different. And if you want to make sure that the system is working all the time as intended, then you need to do continuous validation, testing, and maintenance. However, in some applications, this may be a problem. For example, in health, having the wrong explanation may be worse than no explanation at all. So we need to make sure that the explanations are really very, very good. GDPR already has been used, this Article 22, for AI. For example, in 2019, some French school to put video surveillance for security, and then some parents took that to court, and the court in 2020 decided that that was illegal for 3 reasons. One, they didn't have the competence. For example, they couldn't decide to put cameras. This is something that sometimes we don't think about it. Do you have the power to make the decision to use something? Then they didn't have consent. Basically, you cannot consent to a camera. And of course, in this case, there's no legal basis, which is the other possibility for using a camera. And finally, proportionality, very, very important. The solution was not proportional to the problem being solved. You don't need to video everything to have security in a school. So what about regulation? Well, regulation is complicated. We are seeing regulation in the EU. We'll talk about this in the US. However, I believe we shouldn't regulate technology. We should regulate the problem, the use of technology, and any technology, not AI. Otherwise, I see in the future regulation for blockchain, regulation for quantum computing, regulation for every new technology that we invent. We cannot do that. We need to do like human rights. We need to write generic regulation that applies to a given sector, like we already do with drugs, with food, or with education. Today, there are 3 different cases in the US against the 3 major companies, Google, Facebook, and Amazon. And I guess they will develop this year. There were several proposals to regulate in the US during the Trump government, and all of them were rejected, even one that was proposed by Kamala Harris. And I guess something will happen. Trump, before leaving, created the National AI Office. He took 2 years to do it, but before he left it, so I can interpret that. And I hope there'll be a lot of changes in the Biden administration. In particular, Khan was named in antitrust, and she was criticizing a lot antitrust in e-commerce. Last April, appeared the draft for the proposed regulation on AI. The first problem, I already said it, is regulating the use of the technology instead of regulating the problem. However, there's another bigger problem for me. It takes a risk approach, basically divide the world in 4 types of risk: forbidden, high risk, low risk, and no risk. Well, risk is a continuous variable. So basically, I imagine the game that companies will do, trying to be in the lowest risk possible. So this will be a problem to basically to enforce and to do the self-assessments that you are supposed to do according to this proposal. One article is very interesting, Article 5, that says that you are forbidden to use criminal techniques to distort a person's behavior that may cause physical or psychological harm. So if you apply this to the semantics of the words, means that I cannot offer a cake to a diabetic person as an ad in the web, because that will harm not only psychological, but also physical. That could imply that the usage of devices should be limited in time, or the use of video games should be limited in time, because we're basically doing psychological harm in many cases. It's an addiction. So this will be very hard to apply and very forced, although may be good for humanity, because otherwise we'll be connected all the time to the internet. So something interesting here because of this risk approach, and it's the same that happened with race. For example, skin color is another continuous variable. We, as humans, always try to put things in categories, in buckets, and this may be a very dangerous cognitive bias that we have. If you have a continuous variable, please don't create categories. Don't try to discretize the world when it's not discrete. What some cities are doing, they're registering algorithms, like for transparency, like Amsterdam and Helsinki, making algorithms public. Maybe they can be gamed, but this is an approach. A lot of people are doing auditing algorithms, in most cases against the will of the companies being audited. For example, typically big internet companies. But last March, the first paper appeared that basically does a full audit with the cooperation of a company. This was a company doing hiring people, and it's where you can see it. It's very interesting, and this is from Northeastern, as one of the best auditing algorithms teams in the world. We have a lot of bad human practice in our profession. I will not do this to save time, but I'm sure you know all of them. These are typical things that they start with, I guess, trial and error way to do things. Imagine if construction were done by trial and error like we do things. Some professional biases. We are with the hype of big data, when most companies in the world will never have big data. We need to focus on small data. And if you're interested in that, I wrote an essay in KD Nuggets in 2018 about small data. What about the coders, the designers? Can their bias be transferred to the code? Well, I'm using in my bias talk that's available in YouTube, a data science paper of University of Virginia, but lately in Norway, they showed that the bias of the coders is transferred to the code. So possibly software that is done by women will be more empathic than software done by men. And this is something that no one has tried yet. And in evaluation, well, for people that review papers in conference, we see things like this all the time. They don't choose the right experiment, they don't choose the right test data, they don't choose the right metrics, they don't choose the right baseline. And this is a great talk of Julio Gonzalo about this. So what we can do to finish? We can analyze for unknown biases. It's not easy, but we can try to mitigate the problem with data. If that's the case, we need to make the model aware of bias, and we need to make the user aware of bias. So we need to inform the user about all possible things that are basically potentially modifying their behavior. And finally, in evaluation and deployment, we shouldn't fool ourselves. We should be very tough with our software, do all the tests that you need, do the most tough comparison, and probably the result will be that we are not improving anything, but that's the truth. So recommendations for us, remember the limitations I mentioned. Please remember these limitations. Say, I don't know when you don't know. Try to have a code of ethics. Try to have humans in control and not humans in the loop. We are playing God, so let's be accountable and be responsible on that. And remember that ethics is a bit like privacy. It doesn't depend only on your ethics. Depends on the ethics of your providers and also the ethics of your clients. Ethics is a network, like privacy is a network, and we need to be careful. So the final messages, remember, everything is a reflection, sometimes amplified, of our world. There's no virtual world, it's the same world through the different mirror. We need to be aware of our own biases and ethics to start solving these problems. And then remember, ethics is complicated. Like Heather Henderson says, can AI algorithms ever be ethical? As I said, no, because they're not human. But even if we believe they can be human, this will be an issue, especially, and someone has to say it, because you cannot have AI ethics without ethics. So start with the ethics and then worry about AI ethics. Otherwise, we'll get problems. So my main worry is not artificial intelligence, it's natural intelligence. I see that in every election, sadly. And otherwise, we will have this kind of a black joke that says, prove you're not a human. The robot says there are no more humans, and they both laugh. Not because they kill the humans, because we kill ourselves, as Harari will say. So we need to be careful about what we are doing and not make ethics to run behind technology as usual, but think about the risks and about the possible harms before that. So with that, I can take questions.
Thanks a lot, Ricardo. Excellent, awesome talk. And I will just try to summarize in a few words here, the take-home lesson as you put. Humans in control, humans in the loop, AI solutions to extend ourselves and not to replace ourselves or our authority or decision-making. Awesome. So I have a few questions here, some from myself and some from the audience. I will start with the audience here. The first question that I have is from Professor Marcos Endler, our partner in this Conexão Rio-Campinas. He is here with us. Marcos, would you like to read your own question, and please go ahead.
Okay. So good evening. So thank you very much again, Ricardo. It was an honor for us to have you talking here for us on such an important topic. So it's a pleasure, actually. My question is actually if the problems that you stated, many of those of the bias and the lack of privacy and so on, isn't it a natural consequence that we are developing so many systems so fast, looking always on the profits and on shipping the products on some very tight schedules and don't having time to think about the consequences of the use of the system, or not so deeply, I mean, as it should. I mean, as I would say, isn't a real consequence that we are developing, that we are so dependent now on software and AI and so on. Maybe 50 years ago, we were not so much dependent. So maybe the developers could also have more time to think if their program was running the right numerical calculations in order to get the right predictions. And now we have to predict all things together. And maybe this is the problem. And so the engineers don't catch up with this problem. Could you comment on this, maybe?
Yeah, very good question. So the first thing I will say that something that sometimes we forget is that if we start using technology too much, the number of problems will grow the same way. So if something grows exponentially, the number of mistakes also will grow exponentially. This is just a law of mathematics, even if it's a small percentage. So this is why we are seeing already thousands of problems reported. I imagine that the real number is more, but we don't know it. Like, because we have another bias is that we like to talk about our success, but we don't like to talk about our failures. And you know that we have more failures than successes. Imagine if we have a book of all the startups that fail. Maybe we have much more successful startups because we will say, okay, no, don't do this. So this is the first thing. The second thing is that I agree, like, for example, engineers should learn more about ethics and technology. At least to learn about what are the questions that they need to ask. I recently wrote an article in Forbes Technology Forum about the 10 questions that companies should ask themselves before using AI. And sadly, many of these questions are never asked. So sometimes I think awareness will solve like 90% of the problem. Awareness of the questions that you need to ask, awareness of the bias that you need to check, and so on. But sometimes I see even people that really know about the field using everything as a black box. And you know, black boxes are not the best ways. If you're a real engineer needs to understand the black box. We cannot use things like, okay, it works, it's magic. Because if it's magic for some of us, for other people, it's really real magic, right?
For other people, it's black magic.
Exactly, black magic. So we need to basically change the way we think about things. And as you said, and sadly, ethics, I always say, ethics is always running behind technology, and only will catch up technology when something wrong happens, like a woman dies in Arizona. But then they do a stop, and then they continue running, and ethics keeps running behind. So the problem where we need to stop and think, and the same is happening not only with this technology. This is not new. It happened with pollution, and when we have climate change problems now. It happened with radioactivity. It happened with atomic bombs. The only case where I think we acted before seeing the problem was chemical warfare. We decided not to use chemical weapons in advance. Yes. Because I think that's the only example. We need to do more of the same. Basically say, stop, let's see what we want to for our world and do it better.
Very good. Thank you. Ricardo, I was attending a meeting yesterday, and we had present Judah Pearl and Yosha Benjo, and they were discussing that one big problem in these biased solutions is that there is no common sense in the algorithms, and there is no analysis of causality. So do you think that one possible way of attacking the bias in the data and the bias in the algorithm is tying up some mechanisms to analyze causality and try to understand some common sense?
Yes, by all means, causality is something that we are missing because we are using too many correlations. Like, for example, all these Phenology examples are just correlations, and most probably it's purely correlation. So causality, I think, will be something very important to do more. But also with that, I think we need to do more semantics, by basically adding knowledge. Sometimes we are rediscovering things that we already know. For example, in natural language processing, we're rediscovering things we already know, like grammar and other things that if you try to put it in the system, you are adding the knowledge we already have. And the third thing, I think I mentioned it too, but I think it's very important, is how to increase knowledge of the content of the operation of the system, because data is not everything. Data is just what is most visible on the problem. But for example, what about the context? A judge judging has a big context. For example, the same judge to the same situation, if the political situation in a country changes, may have to decide something different. Also, if the law changes. So sometimes, for example, the data doesn't include the changes in the law, and that can change the decision. So we have all these things that we believe that we can do more than we can, because we are not taking account, as you said, causality, context, and semantics. I would say these are the three main things that we need to add to this. And I would think that it's not human intelligence. We are creating a different type of intelligence. This is intelligence where the skills are there. They are faster, they have better memory, they can do brute force because of that, and we cannot. They don't have some limitations that we have. But on the other hand, they cannot think like us, and for example, they use much more energy than us. So the brain is amazing, so in the efficiency of energy.
Very good, thank you. I have a question now from Maria Eduarda. She is asking, do you see or do you envision that at some point in the future, we are going to be able to develop algorithms that don't have bias? My personal opinion is that probably not, but I would like to hear your opinion on that.
Get rid of bias. This is something, first, because of human. Second, because there are some biases that we don't know. We're not aware until they appear, until there's a problem. But I believe we can mitigate them. And the first way to mitigate them is to make people aware of them. So for example, for me, it was natural to say men instead of saying humans, because I was trained like that. But I trained myself to detect my own biases, and now I say human beings, people, and not meant to say humans. And this thing happens all the time. It's encoded in the language. For example, how do you say accountability in Portuguese?
Well, there is no word for that. We have some candidates.
That's my point. We don't want to be accountable in Spanish or Portuguese, so we don't have a word for that. That's not by chance. So the language also encodes a lot of things that shapes us culturally. So I'm sure you have to say something like rendizado de contas or like in Spanish, but a lot of things are encoded in the language. So awareness, I would say, solves 90% of the problem. So if the designer is aware, if the coder is aware, if the user is aware, if the system is aware, we're already doing a lot of things.
Yes, I agree with you. Now I have a question from our colleague from Chile, Professor Domingo Mary, who I also thank for accepting to be one of our speakers early in 2022. So Domingo is thanking you for the great talk, and he is saying that you mentioned some efforts in the European Union and North America for regulation. Are you aware of any regulation in Latin America in general?
So I think there's no regulation yet in Latin America. So what we have is many strategies in AI that include as part of the strategy that they will need to regulate. So we already have, I would say, Colombia is one of the best. We also have Brazil. We also have Chile. We have more on digital government in Uruguay. We have also draft in Peru. I know Costa Rica is working on one. Mexico did a multi-actor approach that is very, very interesting because you have a national consensus that doesn't come from the government, and then the government doesn't use it. Argentina did one, the previous government, and put it in a desk because the new government didn't like it. So we have our own problems on this strategy, but I believe that the most important thing here will be to have coordination. Something that didn't happen for COVID, and we should have, the same should be true in AI, because if regulations are different, I see where companies will go. Companies will go, the startup will go to the less regulated place to do things. So we need more coordination also at the world level.
Very good. Another question now from Gabriel. Gabriel is mentioning that we also have the challenges regarding data that are synthetically generated. So how do you see these problems of biases when you put in the game something like generative adversarial networks? So it seems to complicate things way more because you need to differentiate what's real data, what's synthetic data, if the synthetic data is biased by itself or is trying to mitigate the bias or increase the bias. So how do you see this?
It's a very good question. I don't think I have a clear answer to that. I'm not an expert on guns, but if we can generate synthetic data that's not biased, that will be amazing. But the question is, if we know to do that, why we need artificial intelligence?
Yes.
So we have a paradox. If we already know what is the right data, so maybe we just know how to solve it. And the truth is that in many cases, we don't agree. So for example, instead of having bias like neutral data, I would say many times you have data that has multi-view point of view. For example, if you want to discuss things like complicated, like abortion or euthanasia or other things, you don't have one answer. You have multiple answers, and then you need to take in account these different, for example, religious differences, cultural differences. And then I would prefer something more smart that says, look, I cannot answer you, but I know that there are 6 different views, and these are the arguments. You have to choose is the best answer for you. Because otherwise, if we have a single answer, we are biasing people to the dominant view, and we know that the dominant view is not always the right answer. Like, for example, if we go back 500 years, slavery was okay. If we go back 100 years, women not voting was okay, and so on. So if we want to change the future, I think we need to don't use data from the past. And that means maybe we shouldn't use AI. We should think everything from scratch.
Which goes in the direction of not trying to ingest all the data that's out there and try to develop algorithms that are robust to be trained with small data. This is very important. Very good point.
Yeah, I think small data also is much more difficult because you need to be sure that how good is your prediction. Another problem that is in the way we evaluate things is that we are using accuracy, which is an average of success.
Yes.
So we are not checking what is the harm of failure, but also if you give me 90% accuracy, I'm sure that basically that means that you have 100% accuracy for the easy problems and 60% accuracy for the difficult problems. For the easy problems, it's easy. For the difficult ones are the ones. So please try to focus on the problems that are really difficult. I don't care about the average. Average is a very bad number to measure. We need to know the distribution. We need to know the variance. We need to know error analysis. How many papers do error analysis? Very few.
Yes. And this goes with your lesson also here. Accuracy is not the key. Impact is the key. Impact of the errors. Very good.
Yes.
I have a question now from Marcelo. Thanks for the presentation. What is your view on opaque versus transparent models and proposals such as having public policies forcing companies to prove transparency. Transparent models cannot perform as well as opaque ones before employing opaque models. It's like some companies claim that if they need to explain the answer, the algorithm itself will be worse. And how do you see this dichotomy?
That's a fallacy. And
I
this
agree.
Is not always true. This is not always, there's a myth, and there's a very interesting paper by Cynthia Rudin that shows that that's not true. In fact, in some competitions, interpretable models have won over deep learning. So this depends, and the problem depends on the data, depends on many factors. So it's a myth that to have more interpretability, explainability, you will lose accuracy. But even if we lose accuracy, I don't care, because accuracy is not the key, right? so this is the other part of my answer. I also remember many times we're deciding things that we should leave to the domain expert on the problem to decide. For example, whenever you are using accuracy to decide the operation point of your algorithm, you're already deciding something that maybe is incorrect. For example, if you are predicting an illness, what I care is about the right ratio between false positives and false negatives. And if you ask a doctor, the doctor will tell you that they're willing to see 10 people that is not ill to basically do not miss any people that is ill. And that is a different operation point that will not be on the default values of the black box you are using. And that means that you need to basically put it in a different thing. And I don't mind the accuracy that you get there. What I want is that the doctor is happy, that he's seeing a lot of people and making a lot of people happy and saying, you're not ill, don't worry, the machine made a mistake. Just to make sure that you don't miss a person with cancer.
This is a very good point, because sometimes students get mad or unhappy because they submit a paper to CVPR, for instance, and the paper is not accepted because it was like 0.5% lower than the competitor, but accuracy is not everything. So this is an important lesson that everyone should take into account. I have a question now from Antonio, and I will complement that with a very good book that you mentioned in your talk, which is Noise by Daniel Kahneman. It's an amazing book. And in one of the situations discussed in the book, he says, judges, when they judge in the morning, they are more positive than when they judge in the afternoon, just after lunch. So this is one. Yes. So this is one problem that we have in terms of humans deciding. On the other side, we could have the algorithms to help, but we know that the algorithms also can be biased. So Antonio Pedro is asking here, how can we convince authorities to adopt such systems that we know beforehand that might be biased?
I would say that in this case, we need to use these systems as support, not as decision makers. We have a problem there because we have a cognitive bias to basically tend to agree with systems supporting us. So basically, if you get a recommendation, you have an anchor bias and also a confirmation bias to what the system is recommending you. But we need to have what you say, human in the loop, but I prefer to say humans in control. So you need to have a judge that is in control of the result. And basically, even informing the system why it's not taking the same decision because of, for example, missing context, missing a law argument, or whatever is missing, that even you can say, okay, this time I will be more lenient, and because of other human reason, you change your verdict. So I would say that we need it. So we always have this false dichotomy of computers replacing humans. We need to work together. So
yes,
we are
different,
we are complementary, and we should be working together. But we have people trying to force us to take a decision when the best decision is let's work together.
Yeah,
you are good at this, I'm good at this, and let's try to do system that solve things that people don't want to do, not system that replace us, because I believe we are.
I totally agree with you, and this goes in line with the Humans 2.0 or 3.0, according to Max Tegmark in that very good book.
So Anderson, I would love to keep talking, but I have a meeting in 2 minutes, so maybe
yes, I would like to wrap this up, thanking you again for the very, very good talk. And the chat is crazy. We never had like this many questions and comments and congratulations. So, Ricardo, thank you very much.
If you can save the chat and send it to me, because you don't have that option, I will appreciate it, because then I can check the questions, and I think they have been very interesting.
I will definitely save it and send it to you. And if you can share the slides later, it would be great.
Yes,
so,
I will do that. I will send you the slides.
All right. So in the name again of the Institute of Computing and also the Pontifical Catholic University of Rio de Janeiro, we thank you very much for your time and the excellent presentation. Thank you.
Thank you very much.
Thank you, Anderson, Marcus, and muito obrigado to all my Brazilian friends. That many people also speak Spanish, like Domingo, Mauricio from, I guess he's in Brasilia, and other people that I know. So thank you for coming.
Obrigado. Thank you.
Obrigado.
Muito obrigado a vocês.
Bye.
Parabéns.
Bye-bye.